We're in this wild new era of building software. I mean, with AI, you can go from just an idea to a full-blown app faster than anyone ever thought possible. It is a huge leap in speed and creativity. But, and this is a big but, when you move this fast, you have to ask a really important question. Are we actually building things that are safe? Okay, let's get into it.
You've probably heard this term floating around, vibe coding. And it's pretty much what it sounds like. You just describe the vibe, right? The feel, the function you're going for, and an AI just translates that into actual code. The number one advantage here? Pure, raw speed. We're talking about turning your vision into a real thing in hours or days, not weeks or months.
And look, this isn't some abstract theory. It's actually changing people's lives. I saw this comment on Reddit, and it just nails it. This is how vibe coding is making tech more accessible to everyone. People are kickstarting whole new careers, building products, doing things that would have been impossible just a few years back. It is a massive unlock for talent.
Okay, so everything sounds amazing, right? But here's the sharp turn. With all this excitement, with all this incredible speed, we've got to stop and ask the one question that too often gets lost in the shuffle. Is any of this code actually secure? You know that feeling when you run the code and it just works? Well, that can actually be one of the most dangerous phrases in all of development. Because code that's generated by AI can look totally fine on the surface, but underneath, it's often hiding some pretty serious vulnerabilities right in plain sight. Let me show you a couple of real-world examples. So check this out. The AI Red team over at Databricks ran a test. They asked an AI, hey, build us a simple multiplayer snake game. And it did. The game worked perfectly. But here's the problem. For the networking part, the AI decided to use Python's pickle module. Now that seems innocent enough, but it opened up a massive security hole for what's called remote code execution. That means an attacker could run whatever code they wanted on the game's server, a huge flaw just hiding inside a perfectly working game. And it didn't stop there. In another test, the team asked ChatGPT to build a tool to parse a really complex file format. And again, on the surface, it worked. But when they dug in, they found it was loaded with memory corruption bugs. We're talking about nasty stuff like heap overflows, where a hacker could use a malicious file to make the program crash, or even worse, take it over completely. So, why does this keep happening? Well, the most important thing to remember is this. AI models are incredible pattern matchers, but they are not security engineers. As the team at Appright put it so well, they don't have a sense of responsibility. And AI just generates code based on all the data it was trained on. And if that data includes bad, insecure patterns, well, the AI is just going to spit those right back out. So how do we fix this? Now, the answer is definitely not to just stop using AI. The answer is to change our entire approach. We have to adopt what's called a secure by design mindset. It's a really powerful idea that cybersecurity agencies all over the world are pushing for. And this mindset really stands on two key pillars. First, there's secure by design. This means security isn't some feature you tack on at the end. It's a core goal from the second you start planning. Then there's secure by default. This just means the product is safe the moment a user fires it up. No need to go digging through complicated settings.
And this is the perfect way to think about it. You don't pay extra for seatbelts when you buy a new car, right? They come standard because they are absolutely essential for your safety. Security shouldn't be a premium add-on you have to pay for. It should just be the default, included for everybody.
And listen, this isn't just some fringe idea. The big guns of cybersecurity, we're talking the NSA and CISA in the US, the NSCSC in the UK, they're all pushing for this exact shift. They are telling every company that makes technology to start taking real ownership of their customers' security. Okay, so that's the big picture mindset. But what does it actually look like in practice? Well, adopting this mindset means weaving security into every single step of your development process, creating what we call a secure pipeline. A modern pipeline is pretty straightforward. You code, you build, you test, you deploy, and you monitor. To make it secure, you have to embed security checks at every single one of those stages. It's not a one-and-done check at the very end. It becomes this continuous loop of making sure everything is safe. And the good news is we have amazing automated tools to help with this. Think of them as 3 different inspectors for your code. First, you've got SAST. That's like an inspector who reads the blueprints, your source code, to find problems before you even start building. Then there's DAST. That's the inspector who comes to the finished house and starts flipping switches and running faucets to find problems while it's actually running. And finally, SCA is like a background check on all your suppliers, all those third-party libraries you're using, to make sure they don't have any known issues. Putting these in your pipeline is like having an automated security team working for you 24/7.
Okay, so that's the high-level strategy. But let's get really practical.
What can you, as a developer, do right now, like today? Let's break it down into a simple, concrete checklist.
Rule number 1, the cardinal rule. Never, ever, ever trust user input, period. You have to assume that any data coming from a user could be malicious. If you validate and sanitize everything, you protect yourself against some of the most common attacks out there, like SQL injection and cross-site scripting. And using tools like an ORM can be a total lifesaver and automate a lot of this for you. Next up, secrets. We're talking API keys, database passwords, all that good stuff. It is a massive no-no to ever write these directly into your code. I mean, if you commit that to a public GitHub repo, it's pretty much game over. Use a real secrets manager. And please remember, anything in your front-end code is, by definition, public. Everyone can see it. And hey, if you're still thinking, the AI is probably good enough, I don't need to worry that much, well, I've got a number for you. Research from Replit found that up to 40% of AI code suggestions might have security vulnerabilities. 40%. That is an absolutely massive risk to take without doing a proper review.
So, reviewing code is non-negotiable. Yes, but what if we could do more than just clean up messes after they happen? What if we could actually guide the AI to write better, more secure code from the very start? Well, that's where the power of security-focused prompting comes in.
And this isn't just a gut feeling. We've got hard data on this from Databricks. They tested different ways of prompting in AI. A generic security prompt? It helped a little. Being specific about the programming language? That was better. But look at this. Self-reflection blows the others out of the water. It cut vulnerabilities by nearly 50%.
So what is this magic self-reflection technique? It's so simple, it's brilliant. After the AI generates a chunk of code for you, you just feed that exact same code right back to it and ask, review this code and identify any potential security vulnerabilities. You're basically using the AI as its own code reviewer. You're turning it against itself, in a good way, to make your code safer.
And that really brings us full circle. Look, AI is an absolutely incredible co-pilot. It will help you build faster and smarter and better than ever before. But at the end of the day, you are still the pilot. The final responsibility for shipping software that is safe, secure, and reliable, that still rests with you.